Good afternoon, everyone. Sorry for the little technical hurdle. It's called Surface devices with specific Surface dongles that work only on Surface. So my name is Peter, and I'm going to try and walk you through only 25 minutes, which is way too tight. I don't have a lot of slides. I'm just going to try and do demos. Sounds good? It was planned for 3 o'clock, which 3 o'clock is like everyone's falling asleep time. So I was like, I'm not going to do slides, but I got a few of them, but not that much. I'm a technical trainer here at Microsoft. So originally from Belgium, moved a bit more than 3 years ago. And I think I have the easiest job title within Microsoft. Guess what I do as a technical trainer? Training. Yes. Helping customers all over the globe. It's all virtual. That's the downside of the job for now. So that's why I'm excited about having actual people in my audience now. It's training customers on the Azure technology. So when I heard about target audience is SREs, I'm like, I'm not going to talk about Azure. Well, maybe a little bit. I'm not going to talk about AI, although I had a few during the break actually asking, like, are you talking about AI? And I was like, aren't people fed up with the whole AI thing nowadays? So it's not AI. I hope that's fine. If you got questions on AI, I'm happy to bring them in. Apart from that, you got all the contact details, so feel free to reach out. Now, what is SRE? Who's working as an SRE? Raise your hand. Good. Who has no idea what SRE is? Good. Some of you are actually on either side, so that's fine. Site reliability. What is the first thing coming to mind when you think about it? For the non-SRE folks in the room, any guess? Safe, yeah? Other, yeah, I'm expecting active participation. You want slides? I can flip to another deck. No, actually, I don't. For the non-SREs, like what is coming to mind? Resilient, yeah. Making something running as good as possible. How do you validate that? When do you know it's running healthy, it's running reliable? Metrics, yeah. A baseline, yeah. SLA, SLOs, good. And how do you get all that information? Like, how do you define your baseline? How do you get your SLOs? How do you know what number to pinpoint? I love that. I like pleasing the presenter. I get it. That's good. That's good. Thank you for that. So to me, the SRE is a stress testing running engineering. Why? Because I know the answer, thanks for the ones who participated. That's all fine. But at the same time, you still need the tooling to get to your baseline. How do you know if 100% is good enough? Actually, anyone asking for 100% SLA, SLO, SLI, you got all those acronyms, right? I remember years ago, almost 30 years ago, one of my first jobs was literally building physical data centers, like the power, the cabling, the cooling. And then a little bit after talking to customers, where they go, oh, but we want 100% high availability. Now, I'm originally from Belgium. It's a super small country. Half of the world doesn't even know we exist. And still, customers were asking for 100% high availability. Honestly, we never achieved 100%. And there's no sense in having 100%. Unless you're maybe, I don't know, the big Microsoft, the big Google, maybe in a finance organization. But even then, you still need to hammer your environments. And that's what I'm going to talk about and show you. Why? Because you need load testing. So what is load testing? There's a formal definition here. It means you're going to simulate load and learn from that. What happens with my application? Whatever it is, can be a web app, can be containers, can be pretty much anything. I'm going to hammer my environment and I'm going to learn from that impact. And based on that, you're going to build your service level agreements. You're going to build your baselines. What happens if I got 50 concurrent users? What about 500? What during the week? What during weekend? And so on. So the actual tooling to get to all the other acronyms is load testing. That's one part of it. But load testing is boring. Why is load testing boring? Repeatable? Yeah. What do you want to get out of it? Yeah, so you're going to run simulations, right? But against what? Do you need to build your production environment to then find out, like, oh, over the weekend, I'm going to hammer it. I'm going to simulate 500 users, 5,000 users, maybe 50,000, 500,000, like simulating a cyber attack. But it's hammering your production environment. So what we have now, and it's nothing that Microsoft invented, nothing that Peter invented, but to make it more fun, it's not just load testing. We're going to do chaos engineering. A lot of engineering today. So who's already doing chaos engineering? And are those the ones that are also SRE engineering? It's typically the same team, right? So what we're doing with chaos engineering, that's where I think personally the fun comes in. This is again another official definition, which is experimenting, typically against your production environment, with the one and only goal to blow it up. How much more fun can your job become? Here you go. You got a production environment. In my case, we call it Azure. We throw a huge amount of money at it to, at the same time, build these impressive environments. My demo environment is not that impressive, to be honest. And then you can start playing with it. You can break it down, and we love it. The more you're going to break it down, the more we learn from it. If you're a bit into technology, I would say anyone try to become a chaos engineer. It's the most fun part. And if that doesn't work out, you can become a trainer. Yes. Oh, so you're agreeing with, you're the stress testing running engineer? Cool. At least there's something right on the slides. So to do that in Azure, that was basically my pre-last slide, so that's easy. We got two tools. We actually got a few more, but I want to stick to the basics. So we got Azure load testing to do load testing. How hard can it be? Every now and then, Azure terminology makes a little bit of sense. And Chaos Studio. Who's already using Azure load testing? Good. The whole room's going to learn something. Who's already using Chaos Studio? Anyone doing Chaos Monkey, Chaos Mesh? Other tools that I'm not allowed to mention? Good, good. I would say we've got a few screens all over, but if something becomes too small on this super small desk, it could become a little bit challenging. But I can zoom in, I can zoom out. So let me know if it starts to become a little bit blurry. So the starting point, who's never done anything with Azure? Good. AWS? Good. Who's not in cloud yet? You're all in cloud? Awesome. Who's on GCP? Who actually more GCP folks here? I don't know anything about Google Cloud. I'm sorry. But it's all cloud. It's all same thing, right? It runs outside of your basement. Good. So this is the Azure portal for the ones who don't know. It's our management interface, one of the so many options if you don't like scripting or tooling. So I'm going to start with load testing. It's already pre-deployed because someone only gave me 25 minutes. So as a scenario, I have a few workloads, web servers, what we call web apps, because they're no longer running virtual machines. And my load testing is, I'm going to come up with some number where the number could be the number of users, number of connections, what kind of traffic. Imagine you're, I don't know, the next YouTube or maybe Netflix, why not? Obviously, you're interested in how many users do I have every single hour of the day, but at the same time, you might also try and find out how much data traffic do I have. So depending on all those scenarios, you're going to move that into a testing. Now, there's two options. You can use JMeter. It's Apache JMeter open source or Locust. So initially in Azure load testing, it started with JMeter because it's considered one of the, I don't know, more standardized, I think, ways to do this. The cool thing is that, yes, it's running in Azure, but it's absorbing an open source mindset. Why? Because a lot of customers, even before cloud, yes, we still have customers not using cloud, they already run load testing against their on-prem environment. Typically JMeter or something similar. But now you're going to move the same workload to Azure and you don't have to change your testing. That's like the mindset behind it. So you go into load testing, you create it, and it's going to ask you a few pieces of information. I'll quickly walk you through if you're interested in seeing all the steps. So step one, give me a name, a description, and run the test right after creating. Okay, sounds good. What is your test plan? What kind of requests do you want me to send? I'm going to send a HTTP something. I'm going to target some website. HTTPS something. Let's see how far we can go without typing everything in, because I already have it. Peter.com. Look at that. What kind of HTTP method do you want to run? In a lot of cases, everyone talks about, oh, I'm going to simulate 5,000 users connecting to my website, and that's an HTTP GET. But what if it's a retail environment where you're not only getting information, but you're also posting? Because now you can go as granular as you want, where you're going to go, I got 500 users connecting to my Amazon homepage, but 200 of them are actually ordering something or moving something to the cart. And then maybe another half of them are moving something in the order, and then my payment comes in and so on. So it's not like we're going to target the homepage, because half of the time the downside, the problems you're going to fight are not on connecting to the homepage. That makes sense? So that's the granularity you have here. So imagine we already have all this done. Next, I'm going to define some parameters. So this is where you could target connect to my dev environment. If inside the backend of my platform, there's an Azure tag called dev, staging, canary, early adopter, whatever you want to add into it, I'm going to use that to run my testing. Most important piece is simulating load. A lot of options here. So you can do linear, which means like every minute add 50 other users, run it during 20 minutes, what happens with our systems if we run the test for 2 hours, and how to ramp up. And again, quite a lot of flexibility. Monitoring, integrating with, that's the downside of a little desk. Monitoring, so move this into our already existing monitoring environment, typically Azure Monitor, Azure Log Analytics, or if you're running this together with other clouds, you're going to move this into, I don't know, Splunk, Datadog, or something similar. And then the most important piece is your testing criteria. And again, think about not just hammering HTTP to the homepage, but like anything else that could be important. So from here, we're going to take a little step back. I go in my testing because everyone's, okay, cool, this works. But can you show me? I'm going to try and run one, maybe one that actually worked fine. This is the outcome of it. Again, 25 minutes, and this is only one service. I got a second one to talk about. Now, what do you get from here? You get your statistics, like what is the load simulation? How long does it take? And you got some nice statistics in a table that you can export. You can connect to some specific URLs inside the web page, and you got some dashboarding. Pretty much anything you expect from a load testing tool. Now, from here, you could go, okay, that's fine, but what if I have 50 systems, 25, 500, just numbers, not all that important, and I want to automate this? I just showed you the portal. You can export all the settings. You can run like if you're a Python developer, you could integrate with Locust, so that's one framework, or you can create a JMeter XML file. So you're going to run the test once, you export it, and from there you basically start writing scripts. There's a plugin in Visual Studio Code that actually allows you to automate the whole process. And yes, it's AI inspired. Oh no, I promised I wouldn't talk about AI. My apologies. Any questions? All good? Yes. So, cool. Yes. But that's where we need the second tool. So load testing can only communicate with HTTP traffic. So anything that looks and feels like a web, although nowadays with API calls, it's not really web, but it's some sort of a HTTP protocol. So that's where it could become a little bit, yes, it's doable. Because if you have your database and it accepts REST API calls, then you could run a load test connecting HTTP something to my Cosmos DB or whatever, and that would work. But the mindset here, and that's obviously why I like to talk about two of them, is that load testing itself, knowing the benefits, but also the limitations of what load testing can do, what part of my workload can I actually hammer? That's where now Chaos Studio comes in. Because what we do with Chaos Studio is not only thinking about load simulations, but again, thinking back about the definition, it's purposely hammering your environment, injecting faults. And again, that's to me the most fun part of what that role is about, where you can think about what can go wrong with my workload. It can be anything that's Azure App Services or functions, logic apps, or anything that's basically a REST API call. There is Cosmos DB support out of the product, can be virtual machines, can be containers. A little bit lower if you have Key Vault. Azure Key Vault is like the secret store, which the recommendation out of Microsoft is for any kind of workload, use always Key Vault. But now you can start thinking about what happens if I'm losing one of those components in my architecture. The website might still be up, or there might be a performance issue. And then eventually you're going to dig in, you're going to do troubleshooting. And then all the way at the end of the cycle, which could be the end of the day, right? You're going to find out like, oh my God, it was some network security rule. Somebody disabled some port, and that's why eventually my web app is no longer responding. So you're going to think about what is the architecture, and then you're going to think about what are all the possible issues that we might have in that environment, and you're going to build those faults, and you're going to glue them together. So you can start small, that's the demo I have, but use your imagination and you can go pretty far. And if I do have time, I can talk about some scenarios that we deployed at customers. Still in the same homepage, we're now looking for Chaos Studio. So in short, how does it work? It's using some built-in Microsoft Chaos framework, unless you connect to Kubernetes on like a Red Hat OpenShift if you deploy VMs in Azure, or you're going to deploy AKS, Azure Kubernetes Service, which is still virtual machine based in the backend. It's going to allow you to choose between run me an agent, install a little piece of software, and that's where it's using Chaos Mesh, which is again a global open standard for hammering your Kubernetes environments in any possible flavor. So you go into Chaos Studio, and the starting point is defining what is my target. I'm running a couple of different workloads, any of them not all that important. And now I can start selecting. I'm going to hammer my Kubernetes. I'm going to hammer the whole service, like over here would be my service, or I'm only going to hammer my virtual machines, not the networking piece, not the load balancer in front of it, and so on. Or I'm going to hammer my Azure App Service, my Key Vault, Cosmos database, and I got a few traditional virtual machines as well. So basically, almost anything that you deploy in Azure could now be used in Chaos Studio. So step one is making it Chaos Studio enabled. How to do that? You select your service, enable target. The platform is smart enough to go, oh, network security group, that's not a virtual machine, so I cannot push an agent. So you don't even have to think about that anymore. Once you have your target service defined, that's where the fun comes in. You define an experiment. Same as before, I'm going to walk you through some of the core settings, and then I'll run one that's already created. New experiment, you deploy it somewhere, so not all that exciting here. We pick up permissions for you because you need Azure role-based access to run the experiment, and the experiment itself also needs permissions to communicate with the target. So if you target a virtual machine, it needs to have virtual machine admin permissions. If you target AKS, it needs to have AKS permissions. To me, it makes sense, but if you're not into Azure that much, it's like, how does it all work in the backend? On top of that, it also obviously blocks you from misconfiguring your environment or making sure that no one is misusing the automation engine in the backend to purposely break down your environment. And then you define experiments. So experiments, that's where you can go crazy. So you got steps and branches. So what is a step? A step is like a step-by-step sequence And a branch is where you're going to run simultaneous steps as part of a simultaneous actions as part of a step. So one step could be, I'm going to simulate CPU test loads. This is the list of all the current testing that we have. Don't worry about deprecated. It's because I'm on an internal subscription where I'm seeing different life cycles of services. AKS, obviously, this means you can target your AKS environment. A lot of different options there. Or you got all the other ones. Shut down a service, stop my virtual machine, stop my database, stop my app service, and so on. Or CPU pressure, hammer my web app or virtual machine. Let's do virtual machine. For 5 minutes, 95% CPU. And what is your target? It's MySQL VM. Where now this will only run a CPU pressure for 5 minutes, spiking to 95%. But what if I have some other part in my workload? We're going to add another action. While my virtual machine SQL is getting hammered, my app service that's running in front of it, that's a bit small, is now also stopping during 10 minutes. And after 10 minutes, it's just starting up again. So that would be one option. So now the flow means I'm going to run CPU pressure for 5 minutes. And when that step is done, I'm going to shut down the web app. But that's okay, but maybe that's not really how your production environment works. So what you can do now is adding a new branch. We're basically doing the same thing. But the big difference is that now those stress tests, if you want, like literally injecting faults, are now running simultaneously. My SQL VM is spiking CPU 95% during 10 minutes, and at the same time, we're also shutting down the web app. In a typical Azure architecture, this would mean that one workload in that one region is down. Where then now you could even go more crazy, because now you're going to benefit from cloud high availability. My workload in one region is down, so I'm going to move it to the next region. But what if your next region workload is now also down? That's what you can build with Chaos Studio. Make sense, definition? Start small, go super crazy. I have scenarios at customers where we got 50 steps and 500 actions in one single task, and then running that every single night. Quite impressive, not only to build, but actually to see it in action. So I got one example here. Did anyone take track of time? No. So as long as you're not complaining, I can just keep talking and demoing. Nice. So I'll start with CPU spike. It's an easy one that everyone understands. So I'm going to kick it off and it's going to run. And then from here, this is what I ran yesterday to make sure that my demos were working. So you can see that it works fine. And then when it's going live, I'll move this out of the way a bit. You're going to see that it starts with some pre-testing, pre-validation, and then eventually it's running. And for some reason it failed. That's fine. That's what happens if you just click around and do stuff. But it's going to show you like the live processing. And then obviously that's the other part that typically comes up. Okay, the test is starting, test is running, test is finished, but what's the outcome of it? So in this case, it's my virtual machine. So I would go into my Azure VMs. I don't have the high-end monitoring deployed because it's just a short-living demo. I would search for CPU. And then you can see here a little spike. That's fine. And then if I do last 3 days, there should be a bigger spike from my run test yesterday. Now here you might go, wait a minute, Peter, you did a 95% load, but it's only 50%. Why? Because our monitoring here is always an average. So that's why you hardly will ever see that it really goes up to 90%. Any questions? All good? Yes. Oh, that's far in the back. Do we have the microphone? I guess not. Oh, it's all the way in the back.
First of all, I'm hearing this Azure Chaos Studio first time. It's really interesting. Like we are using multiple tools to generate traffic and doing this, and it's there in Azure. Azure, it's very interesting. But my question is really, can we integrate this with our DevOps tools, like our Azure DevOps test cases, or can we integrate it with our CI/CD pipelines so that I can create experiments here and then I can call it in my pipeline, or I can put it in my test cases so that I can have tests running every day. That really helps me ensure my site is healthy. Yeah.
So the good answer is I'm going to do one click. And that's what we call our Azure Mission Critical Framework. So what's the idea? And you see the link here, it's going to the GitHub repo. So first of all, thanks for the question because it's a nice segue to the last part here. So we got load testing, standalone service. We got Chaos Studio with everything behind it. We're now ultimately go, okay, it's a cool demo, hopefully. Was it a cool demo? Should be yes, but I know it's afternoon. Thank you for that. But in a real life production environment, we want to automate this. So the way to do that is indeed gluing this into your CI/CD pipelines, DevOps scenarios. I'm inside my DevOps. This is Azure DevOps, but you can do the same on GitHub, GitLab, Octopus Deploy, TeamCity, and so many other. In your pipeline definition, in Azure DevOps, we typically make it a little bit easier because we give you a pre-built task for this, where the task is called Azure Load Testing. Give me the name of your subscription, the name of your testing file, and the name of the resource or resource group. So the way this works, you go back into load testing. Not here, Peter, but here. So once the testing definition is done, you select it, and up here you have set up CI/CD. From there, it's going to ask you, like, what is your DevOps backend? In my case, my Azure subscription is connecting to Azure DevOps, and you just selected where do you want to fit it in. If you already have this all done, and you go, I just need the testing file, you go one level deeper, configure test, and that's going to allow you to export it somewhere in one of those options. For now, it's creating that locust file for the Python scripts, or it's creating the XML or YAML for the JMeter. Do you move that into your source control? Anyone who's adapting tests, you can use anything from your DevOps backend. And with that, I think I'm out of 25 minutes.
Yeah, how the output looks. If I have to see the metrics, failures.
I don't have an example for Chaos Studio, but you can connect to your experiments using REST API calls. So you would basically run curl something pointing to the resource, giving the permissions to the pipeline to trigger, and that's how you could automate it. Good. Yes.
So that looks like a lot like the Iris framework.
You were a Google guy, right?
Nope, I'm not Google.
No, not you? Oh, you're the only non-Google in that area? Could be, I don't know. I don't know the Iris framework. Are they using the same like JMeter locust, or you don't know? I think there's a reason for it. We could look if it's using like the same open source frameworks, but my assumption is they do. It's the same with AKS, Chaos Mesh. It's just like a Kubernetes open standard that if you want to do chaos engineering against Kubernetes, that's like the go-to scenario. And we're just, instead of, oh, we can do this better, we're just reusing that technology.
Thank you, Peter, for the reference. I'm Google guy. If you have questions, you can ask me. I wanted to ask you, what is the output or what are the results of the Chaos Studio? With the load testing, you showed us it is a dashboard, some stats.
Oh, so you mean like visibly seeing the outcome of the test?
Yes, it's there.
Yeah, so that's where, again, the integration with Azure Monitor or some other monitoring tool, if not in Azure, would still be needed to see what's actually happening. So if I run my chaos scenario like the CPU spike, like I showed you, you can go into the Azure resource and then check the monitoring, and it's going to show you like, oh, there's a spike. If you have a task that's, for example, stopping the web app or disconnecting the network, or I don't know, losing the key from the secret store, you're going to see all that in like the Azure action logging.
So running basically the chaos versus production environment should give me a way to test my, I don't know, SRE runbook or something like that.
Yep. But then the dashboarding is your traditional dashboarding.
Thank you.
But the thing is that you could now run the outages before your customer calls you that your system is down.
Thank you very much. And then my question related, I'm just thinking, what about real use cases of like usage, like this case? For example, I'm working as DBA, right? Supporting business applications, and I want to load my system. Maybe I want to confirm that critical functions still, I can still operate them. So just like real use case, could it be, for example, I experiment in studio and at the same time, maybe monitor my real production environment like for, something like that. I just want to make sure that I understand correctly how I'm going to use it.
So again, if you just think about the core of chaos engineering, which got invented by Netflix, I don't know, 15 years ago, the main goal is hammering your production environment to learn from outages, because you're injecting faults on purpose. I'm going to remove the network connection. I'm going to disable some keys. I'm going to break down. I'm going to CPU load, and all of those together, right? Where again, the main goal is the more you're going to hammer your environment, eventually the more stable it's going to run. For now, typically we're all, maybe not all, but most of the scenarios in long time ago, in my case, physical world and then cloud, it's like it's all running fine until it doesn't. And then you're going to start looking into what was the root cause. For now, by using that concept of load testing and chaos, you're going to move that into a proactive scenario. We're not going to think about, okay, the website is running. What if we have 500 users? Because last week when we had 500 users, it blew up. So now you're going to try and learn from that. Or my DevOps pipeline injected some new Azure bicep and there's an error in there. Or we lost that Azure region, I don't know, West US. We got a failover, but oh, too bad, we didn't want to pay for East US, so it cannot handle the load. So think about all those scenarios where stuff can and definitely will go wrong, but you're not waiting until it goes wrong. You're going to test them up front. That's the main use case. So we got, again, one big customer out of the training that I remember, the one with that super, I think, quite impressive testing scenario is an online retail where they cannot control anything. And you might go, okay, everyone talks about the typical spike load, like in the US, Thanksgiving or any other holiday, right? But there's so much more if you're in retail where you as the retailer, you do not control it. Like for so long, we used COVID and the pandemic as an easy example, but nobody knew. But what if all of a sudden, I don't know, maybe Seattle is a bad example, but imagine that it's like sunshine every single time of the year when you're in California. But all of a sudden, because of the weather changes, there's 1 week of hailstorm. If you're the retailer, you want to adapt your business to that. But you cannot scale, but you got the orders coming in. So all of a sudden you might go, oh, it's, I don't know, the second week of April or something. And this is our traditional business, apart from like maybe Easter coming up, right? But apart from that, apart from the Easter hiccup, our usage, like users connecting to the site, is pretty stable until something happens. And I think you get a lot of examples like how the world is shifting every couple of hours these days, right? That's where now you cannot control it anymore. And that's where those testings will actually help you.
Okay.